Hi, it's so excited to be here today with all of you. And it's so excited that I can give this talk. So our today's topic is the power and the elegance of reflection. So before we get started, let me introduce myself. I currently work for Intel Corporation as a software engineer in SDIX group. William Kennedy taught me language Go. Before Go, I had many years experience in Java and other frameworks. So at his class, I told myself, hello, he's better to have something to impress me. And he truly did. At his class, he not only taught us how basics about the Go programming language, also he told us how the Go design is sympathetic about underlying systems. So in another word, so his mechanical sympathy truly inspired me. So today we're going to study reflection in Go. So why I choose to talk about reflection in Go? It's truly connected with the project that I'm doing. So my project is Snap. Snap is an open telemetry framework within Intel. Snap, the whole ecosystem, consists of collectors, processors, and publishers. Collectors can collect data from all different sort of the resources. I wrote Snap collector for Elasticsearch, Cassandra, and Redfish. So the challenge I had was those data has no common interface. So I cannot simply just write a program against it. And some data have those kind of arbitrary field, type, and depths. And some I don't even know because I need to drill down to the data. So I don't know their representation beforehand. So what if my data resource changes? Do I need to rewrite my collector? So that's a big question for me. Let me give you an example. Here's a sample JSON document for the Elasticsearch. So you can see those fields have different types, and they are the representation format in different kind of depths. So it's arbitrary, it's not fixed. And my job is to flag this document out to be this kind of key value pair. So it's like a metric-like key value pair. So the question is, how could my collector accept arbitrary kind of data with arbitrary representation? Even the data representation may be changing, and I don't need to change my collector. It should work. So that's how we're looking into reflection. So let's see what's the reflection. So reflection in computing is the ability of a program to examine its own structure, particularly through types. It's a form of meta programming. This is by Robert Pike at the Laws of Reflection. He also said, a reflection is a powerful tool, should be used with care and avoided unless strictly necessary. I know reflection topic actually is a myth. Many of us probably do not think they don't want to use reflection because it's too slow. Hopefully, after our today's session, see what kind of answer you have, and if reflection could be a best tool for the job. So may I know how many of you have used the reflection at your work? Would you please raise your hand? Oh, that's great, so many of us. So let's see some quotes from the expert. David Cheney said, compared to a disk-seek or network transfer, the cost of reflection will be negligible. And more importantly, William Kennedy said, integrity, readability, and simplicity first. So what does he mean about these three things? So let's look into it. So what is integrity? So integrity is really about the accuracy you read and the write to the memory. And also about performing the behavior, your desired behavior, consistently. Think about how important this is. So without this integrity, so what kind of weird bug issues you could get into? And how hard to debug those issues? And the good news is, reflection provides you integrity. Hope that's wonderful news. So what is readability? So readability is really about to understand what the code is doing and understand the cost of the code. Let's see two simple examples here. It's just multiplied by 2. So you can see the second method actually is much faster. It's faster than the first method. But as we know, the first method actually is what we probably most of us use, right? We don't use the second method. So question to you is, should we sacrifice the readability for the sake of performance? I guess you know my opinion already. Because you see the other people's Apple quotes there said premature optimization and programming misses are the root of all evil. So in my view, if the first method, the performance is acceptable, and it's much easier to maintain. The reason I said that is because everybody can understand that code. Even the non-technical person can understand this code. So I would use the first one. I want to let you know another good news is reflection provides you readability. So later I'm going to show you an example about this part. So what is the simplicity? Simplicity is really about programming efficiency and not wasting your effort. The good news is reflection provides you simplicity. Let me give you an example to understand this sentence. Let's say you're doing the data transformation. If you don't use reflection, you will have to write the code for every type you're going to transform. Imagine how much work that is, and how much effort you might have to put into it, and how hard it is to maintain. So these are the areas I'm listing here. The key reflection is the key enabler. I can give you one example. For example, like a dependency injection framework. In our Go, the function is the first citizen. So you can inject function into function call. That is through the reflection. And by the way, these Go packages is using reflection. So no matter you like it or not, you are using it. So we just talked about how the reflection won't let you miss the integrity, readability, and the simplicity. So as today is a tutorial session, I prepared some examples here. So we are going to study some examples here about basics about reflection, and something applied to interface, and we're going to inspect some integer decoder and struct values. Yeah, let me get to it. Because I prepared the GitHub page and with examples. And this is totally open source. So even after this conference, so you're welcome to come to this repo to play yourself. So I have some Go playground here. I don't know whether you can see the code. Do you want me to enlarge it? Or this is fine? So I take it as fine. Or I can enlarge it a little bit, I guess. You can see actually with on line 13, we define a type called user. It's a struct type. And in this struct, we have 5 fields. They are all in different types or kind. And on line 24, we initiate a user called Cindy. Then on line 33, we get the reflect value of user Cindy. Then actually, we just print out, we just examine the user Cindy, what's user Cindy's variable reflect value kind and the type and the number of field. So let's just run it. So you see the results is print out. So kind is a struct. Type is what? Is main.user. What is main.user? That's what you defined, right? You defined the Cindy is a user. It's in this main package. So it's main.user. And you know the struct has 5 fields. That's expected. Okay, just remember the outputs. See whether you can, I'll show you other examples. I want you to see whether you can generalize something for me. So let's look at another example. Actually, it's pretty much similar. We use the same data type, is user, struct. And then in this one, we did a little different, is we stored Cindy and Bill, 2 users, into a slice. So what do we do here is on line 42. We get the reflect value of slice of user. Then we inspect is the kind and the type. But as you know, this time because it's slides, we show you how to iterate over the slides through the reflection. So basically, you need to just use a loop, go into it. So let's run the example. See what's the output? Here's the output. Is that what you expected? The kind is the slice. And type is the slice of main.user. Yeah, other just print out slice value. So is this what you expected? Yeah, let's look at a similar example for the map. We use the same user type, and we stored Cindy and Bill as a map. And then you can see the map key is a string on line 24. Then we get the reflected value of a user map. We inspect its kind and the type. Also note that I show you how to iterate over the map through the reflection. So if you want to iterate through the map, you just use the map keys. Then you use reflect value map index. So let's run the example. I guess you know the output already. So kind is map, and type is the map of string, and the value is main.user. Let's see the last one for the basic package. So it's similar. We use the same user, but this time we did a little different. For the user Cindy, on line 33, instead of just get a reflect the user value of user Cindy, we get the address of Cindy. Basically, it's a pointer of Cindy. So this address is pointed to the user Cindy. Then we examine the kind and type. As this time is pointer, so we use this kind of v dot element to dereference the pointer. That's how you dereference the pointer in the reflection. So it's really simple. Then you can inspect the kind and the type and number of fields of dereferenced Cindy user. So let's run it. So this is the output. I guess this output is what we expected, because you see the pointer. The first one, before we depointer, actually the type is the pointer. And after dereference, the kind is the strut. Let's see the type. Type is expected, because the first one is the pointer to the main.user. That's what you define. Now after dereference, that's the actual main.user type. So after this 4 example, so what kind of stuff can you generalize? What did you see the difference between kind and the type in reflection? What do you see? So I guess the answer is the kind actually is built-in type. Like a Go built-in type. So it's a strut, it's a pointer, it's a map, it's a slides, right? And the type is what? Type is user-defined type. This is what type you're giving. So you could call this main.user, or you could call this main.admin, anything you define. So just keep one thing in mind. This is very crucial in reflection. So as the kind is built-in type. So kind is finite. That means you only have a finite kind, but you have infinite types. Because the type is what you define. So you can have infinite types. You only have finite kinds. Why I'm mentioning this is I want to see the other example, actually. You can see when we do the inspection, we should always inspect on the kind, not on the type, because the type is what you defined. As we have finite kinds, so you can deal with it, right? So let's see the other example. Here's the interface. It's very similar. As you already know, so I'm not going to go that loud for you. The only difference is on line 34. So what we did is we initialized the user Cindy, and then we store the value inside an interface. So then we get the reflected value of the interface on line 37. Then we start to inspect the kind and type and number of field. So since we store the value inside the interface, so what kind of output are you expecting? We just learned before the basics, right? Now it's just a little different. We just store the value inside an interface. So let's see the results. Hey, the results is exactly the same as before, right? Nothing changed. You see, kind is strut, and type is main.user. No effect. Okay, let's watch another example, see what you see. For example, like slides. Same thing, okay? Only on this line 43, we stored a slice of user inside a interface. Then we examine the kind and the type. Let's just run it. You see the output did not change. Same as the basic package, right? Still, kind is slides, and type is slice of main.user. So you know the map and the pointer are probably the same, right? Probably we don't need to go through all of them. So we just go through the pointer. Okay, sorry. Let's see, this is a pointer here. Only on this line, line 34. You see, we stored pointer to the user into the interface this time. Then we get the reflected value on 38. You know, then we still inspect the type and the kind. Let's run it. The output is exact what we expected. You see, pointer after dereference is just a strut, and the pointer to main.user type is main.user. So after studying this example, what did you learn from this example? So this example tells us the interface is not going to change, underline your value type, kind, and the value. Nothing going to change. So it's not going to change anything. And also, another thing I want to mention to you is, because we just store the value into an empty interface. So another thing you can learn is empty interface actually can store any value, including pointers. So let's go through the last two examples we have here. For this one, I want to show you how the reflection really provides you the readability and the simplicity. And then we're going to examine, like inspect through the struts and see its field name, a type, and the value. So everything is still the same. We have the user type defined on line 13. And then we initiate a user called Cindy. The only thing difference this time is I want to, because I don't have anything, it's just an example. So you can do any like a business function here. But in our case, we just display we inspect the user Cindy. So we can display the user Cindy. So we call this function on 33, display user Cindy. So let's see this function display. What does it take? It takes the input is interface, empty interface. So what does that mean? It takes any value, including pointers. So not specific types. So you can pass into the display function. And then let's see, what does this do? On line 40, like you know, we just get the reflect the value of your input. Then on line 43, we just check, see if your reflect the kind is a pointer. If it's pointer, what do? You need to dereference it. You need to get a value out of the pointer. You just use iv.element to get that value. So after you get that value, what do? You just inspect, switch on the reflect the kind. As we know, we just learned before, we have finite kind, so no problem, right? So you just switch on the kind. So in our case, actually, we just have reflect strut, so we don't have anything else. So in my case, I just see if a case is reflect.struts, hello, call display struts for me, because I want to see the value, okay? And note this program, how simple that is. The code is really simple, it's readable. Why I see it's simple is, you imagine that if we don't use this kind of reflection, so you need to write this kind of code for all struts or objects you can do to transform. Then you can use those kind of, some kind of if-else statements, probably use ... notation, right? Depending on how deep your project is. So your code will be really messy. And look here, display struts. In my case, actually, I only have one case. Actually, you can extend it if you have other case. You just put another case statement. Then display struts actually could be your business function. In our case, because I just show you an example, so you just display the struts. So let's see, display struts actually takes the reflect the value. And I'm going to display the detail for you. Because it's struts, so we can loop through. It's a field, number of fields. And then you can see on line 65, actually we print out the field name and the field kind, right? As you want to see the struts value, so you need to still say, okay, display value for me. For this field, I need to see the value, okay? Then the value is very simple here. You can see the display value, what does it do? It just switch on the input reflect value kind. You see, okay, if it's string, we're going to print out the string. If it's integer, we're going to print out the integer, right? Because you know Go is very type strict language. So you need to do this. So you get everything out. Let's run it. Did you see on the output, you get the struts name, kind, and the value. You get everything. So hopefully this program show you how simple and readable the reflection code is. Okay, we finished our example. So by those examples, we learned Go reflection package really provides us very powerful operations on kinds and the value at the runtime. So you need to remember at the runtime, not the compile time. Also, I have to show you how the reflection provides you the readability and the simplicity. Oh, I forgot the one example. Sorry. I think I need to go back one. The last example I did not show you, right? Yeah, this example is very important. I need to show you. Yeah, this example is going to show you how the reflection going to provide you the integrity. So what does this code does is it's going to decode any variable into an integer. So in our case, you can see on line 17, our input is string 10. We want to decode that string 10 into integer number. Also on line 22, we're going to decode the integer age itself, 45, into age variable, right? Integer. Let's see how the decode int works. You see the decode int function takes empty interface as input and want to decode to number int type. So you can see on this, we all know, like on line 31, we get the reflected value of your input. Then on line 34, we retrieve the value of your integer pointer, because that's what we want to decode into. So we retrieve that. Then what we do is we just switch on your reflected value, input value kind. And here, I want to point out something to you. You see, if you switch the kind, because you see our example, we decode a string into integer, right? So let's see, if you see here, you see IV, you get string, and what kind of error will you get? Panic, right? Because it's wrong type. So you need to retrieve the correct type, because it's expect the int type. And same thing, of course, our example here is simple. It's just set int. So for set int, you need to provide the correct type as well. If you did not provide the correct type, you will still get the panic. So this actually is wonderful. Why I say it's wonderful is because reflection makes sure you're doing the right thing. You don't put the wrong type, wrong thing there, and your program still runs, compiles, then give you wrong results, right? So reflection ensures that if you don't do the correct thing, it's going to throw the error for you. So you will get a panic. Yeah, now I'll go back to this kind of like a summary. What do we just recap? What do we talked? We know reflection is really powerful, and also I show you the readability and simplicity, including the integrity of a reflection. So next one, I'm going to give you a case study. Like I mentioned to you before, I wrote some snap collectors. So the one I'm interested to show you is the refish collector. So I just briefly put a definition here. What is refish? And currently, actually, is new like industry standard is quite popular for the hardware, like a server industry, by using RESTful APIs. So let's see what the refish like a markup API looks like. Hopefully you can see it. So you see the like they could have many servers. In this case, the first page, actually, did you see this kind of blue thing? Actually, is a link. OK, this kind of link you can drill down to. So your first page is a JSON document. Then let's see, we're interested in the system. Let's drill down to it. Then say, OK, now I only have one system in the whole rack. And that's some kind of 437. That's the system ID. OK, you could have multiple ones. Then for this system, you can still drill down to it. You see? You drill down to this kind of arbitrary JSON. No matter the type, fields, or the depths, before you go into there, you don't even know the format. Let's say you go into it. Look at this. For the system, it has the processors, Ethernet, interface, storage, blah, 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 a lot of stuff, right? So you can continue drill down to it. Then when you drill down to it, then you say, OK, I have many CPUs, multi-core. So you can go to CPU. Then you have all this data. It's all in this kind of format. So what my collector going to do is automatically drill down to all the layers and flat all this document out. And give you the, OK, let me show you this. That means give you this kind of key value pair format matrix. So here is just to show you the key. So look at the code. It's really simple. Actually, I put a code here. You can see just this much code. Actually, that's the whole thing for me. And then we can go to the GitHub page. See whether go there? Yes. OK. Yeah, I have this GitHub there, so you can see the code. So basically, we just make a HTTP call to get the page back, right? Then once the page is back, actually, we just call this one. So can you guys see it? So we just call this traverser to drill down to the last layer to get all the thing out. So let's see the meat actually is in this traversal function. That's actually is in the method. That uses reflection. This traversal is here. What does the traversal accept? It just accepts the map of string, and the value is the empty interface. That means any value is fine. Then actually, we just loop through this data. You can see online on 308. Just loop through this data, map data. Then we just switch on its kind. And then in my case, actually, because I need to do something special for strings, I put a string out, reflect out string. You don't have to. Then I put reflect out the slice out. And the thing I want to mention to you is, because like this one, if it's a map, I need to do recursive call. So you need to call yourself. Recursive call. You see, I call IC traversal, right? And besides that, I did the map is same thing. Map, I'm call myself. OK, calling myself to go down, go to my value, right? And the other thing, because like I mentioned, is find a kind. Is building like a primitive kind. So I'm just doing the business logic, do something with it to get data out in the default. Actually, that's my case. Yeah, so finally, I'm going to give you this demo. So what this demo is, it collects data from Redfish, like I just mentioned to you. Then it's going to publish data into the InfluxDB. And then the data in the InfluxDB can be shown up in Grafana. Also, as I'm doing publish, so I just show you a little bit the data could be published to multiple endpoints. So I'm published to the file, so it's on the file system. Also, I publish it to another third-party tool called Hacker. So let me quickly show you that. We'll be done. So can you see my code here? That's very small. I think the first one is not important. You need to see. What I does here is I need to stop my snap. Okay, let me just start it up. Okay, snap is start up. Then I have this code like demo.shell. What does this do is actually I'm use Docker. So it started a full container for me, the Docker container. So what kind of Docker container is Redfish, InfluxDB, Grafana, and Hacker, right? Then you see that those green things actually starting load my publisher, file publisher, and the InfluxDB publisher, Hacker publisher. Then you can see the Redfish is the collector here. So you see it's starting doing that. Then as I told you, I put the data into collected the Redfish. You see it's moving. It's just coming in like the way I want it. Okay. Also, yeah, because I told you we publish it to the Hacker. So let's look at the Hacker. Because that's inside the Docker. So I'm show you. You see this one is because it go to the Hacker. So in Hacker message format, you see both running, right? This is the file. The right side is the file system. The left side is go to the Hacker. And so how to? I need to minimize it. Okay, good. So let's go to the Grafana, see whether, so everything is there. So I already have my data source defined. I probably just need to test my connection. So it's good. Yeah, I happen to have my dashboard defined. So let's just quickly build one now. You see I choose a database called Snap. That's the Influx database name I use. It's here. Actually, you can choose. You see the data is coming. I don't want to like 6 hours, right? I want to like 5 minutes, like that. Yeah, then you can add on to the thing, like that. I don't know, something seems broken here. But anyway. Yeah, these metrics should be just flow in like this. So you can see the data. Then if you loop over the mouse over the data, you can see the metric name and its value. Yeah, this is just my quick demo. So we just show you how the reflection provide you with integrity, readability, and simplicity. I encourage you to use reflection when it's the best tool for the job. And also, I want you to learn, you can learn the reflection by write your own plugins to Snap. And I have some Snap things to give out, like stickers, some links. You guys can, if you're interested, you can use it. So this is my contact information. And this is my acknowledgement to all the people who helped me with this talk and presentation. Yeah, I really appreciate you guys come to my talk today. Thank you very much.